Welcome to our presentation. I am Ioanna, and with Nestoras, we will present to you how we, as a Kaizen Gaming, are leveraging generative AI to automate customer service insights. Can we move to the next slide? So let's first start with who we are. Kaizen Gaming is a game tech company that is focusing on delivering world-class entertainment experience to all our customers. Our main products are casino and sportsbook, but what defines us is how we evolve and build around these experiences. AI is not just an add-on for us, it's part of our DNA. And that means that we're using GenAI in order to power personalized player journeys, real-time context-aware recommendations, as well as AI-driven customer experiences. Our ambition is to be intelligent, personalized, where we treat every player as an individual and not as a segment, as well as technology-driven, using cutting-edge AI in order to stay ahead of how people want to be entertained. And now that we talked about who we are, let's talk about what is the use case that is already creating impact in our company, which is customer service insights. So every day, we collect massive amounts of data that are user feedback, emails, surveys, as well as social media. And basically analyzing this type of data has been manual, slow, and very fragmented. By leveraging GenAI, we are able to leverage diverse data streams in real time, automatically detect patterns and emerging issues as well as sentiment shifts, as well as enable teams to interact with insights conversationally. Using GenAI basically reduces manual work analysis, times to insight, as well as fragmentation across teams. So instead of just analysts spending hours doing the analysis of the data, building static reports, they can focus on what matters most, which is making better and faster decisions. Now that the natural question that comes now is how does an AI system look like? Because we're not talking about a single chatbot, we're talking about an evolution of capabilities. So first, we start with the most basic form, an LLM with just a prompt. And this is a setup that is powerful, but limited to what's stored inside the model's parameters. At the next stage, we integrate RAG, which is retrieval augmented generation, and this is basically giving the model a library. So before answering, the LLM retrieves relevant documentation from external knowledge sources, such as Google Drive, perhaps vector stores or databases, and this dramatically reduces hallucinations. At the third image, you can see that now we're adding tools, which are the model hands, and basically now the agent can fetch files, run queries, summarize sheets, call APIs, or transform data. At the next stage, we add iterative reasoning. So now the agent can plan and can use multiple tools in sequence, where the LLM is orchestrating the multiple steps. And finally, we scale from one brain to many, where each agent has its own LLM, retrieval setup, and a set of tools. So they collaborate much like a team in a company, and some of them may specialize on feedback analysis, others in file management, others in customer insights. And together they solve something that one model cannot. So now that we have looked at the individual building blocks of an agentic system, let's show you how they come together as a working system for our use case. So everything starts with the user. The user applies filters such as the country, the data streams, as well as a time frame that they want. And then after they select the filters, they ask the question. This input is sent into the query analyzer, which is an LLM, and this LLM acts as the system's interpreter. So basically, it tries to understand if the intent is clear. It validates this intent against our metadata, and finally, it extracts the exact parameters that are needed in order to answer the question. At this point, in the orange shape, the system now makes an important decision. Is the question clear and actionable? If not, then it goes back to the user and it asks for a follow-up. Otherwise, it moves to the planner LLM of its data stream. So the planner LLM is, let's say, the strategist of the system. It includes a step-by-step execution plan that is based on the user question, the conversation history, as well as the tools that are available to the agent. Once the plan is created, then the agent can execute it. Each agent has its own purpose-built set of tools, where these tools are not generic. They are designed to perform trusted as well as deterministic operations, such as filtering, aggregations, and calculations. So this is how we ensure consistency, accuracy, and reliability. Finally, the outputs of these tools, they go to the response synthesizer LLM, which is, let's say, the storyteller of the system. It takes the output, the results from the tools, it connects the dots, and then it generates a clear, coherent answer that is presented back to the user. And as you can see, it doesn't matter how many data streams we have, it can handle as many as we want. So basically, what you're seeing here is not just an AI that talks, it's like an AI system that plans, acts, and explains. Nestoras?
Thanks, Ioanna. As Ioanna has highlighted, the initial architecture that we designed, based on the resources and the knowledge that we had back then, it was solid for its purpose. But we hit quickly a wall. The core question became, how do we scale from hundreds to millions of data? So when we began the journey, the data workflow was mostly manual. Another team was sending us pre-processed data that they were in Excel sheets, and we then shared them, we stored them in a shared cloud storage. For the latency of the agent, in order to ensure low latency, we were reading and caching all the data in memory upon startup. Our agent was using Pandas in order to read and perform all the calculations. We even allowed the agent to write its own code using Pandas based on a user query. However, we quickly found out that this didn't work as expected because we didn't receive the right results. So this entire setup resulted in excessive memory usage, and we critically hit the limits of our CX agent pipeline. So we have quickly realized that the fundamental shift was necessary, and we moved from manual processes to automated processes where we actually take ownership of the data preparation. We did everything automated, and we created data pipelines for reliable end-to-end processing using a data and analytics platform. We created dedicated on-premises non-relational database clusters optimized for efficiency, ingestion, and high-speed lookups. We replaced the caching with direct operational database lookups. We added and tuned targeted indexes in ingestion pipelines to optimize frequent queries, and we migrated the data aggregations from Pandas to operational database pipelines. These strategic changes delivered immediate and substantial improvements. First, we achieved 60% lower memory usage, faster queries, a unified architecture, and scalable production readiness. Next, we would like to walk you through a specific use case that we tackled, the challenge to summarize 18 million chats and to create tailored summaries to meet the specific needs of specific teams. So the first step was the data preparation, where we need to fetch all the records that they included valid chats. And the second one was to select a specific model. For our use case, we selected GEMMA, 12 billion model, because our experimentation showed that it had better performance results and it had also lower latency compared with other models. However, if these all steps seemed sound, we faced two challenges. The first one was the context limit. So we had chats that they were so long where we need to split them into different chunks. And then what we did, we generated for each different chunk a specific summary. We then aggregated the summary, and then at the end, we generated the final tailored summary that we had. The second one was about the latency of the model. So at the beginning, we were sending a large amount of data into the model, and you can imagine what happens is that all these requests were sitting in a queue, waiting for all to be finished, and then the others were taking their place. So in order to handle this case, we used batch inference, where we send now a specific sample of a specific sample size of data in order to improve our latency problems that we had. Finally, in order to ensure reliability and control costs, we introduced a checkpointing and fail retry logic, because you can imagine that if a job will fail, we are not going to run again everything from the beginning for the 18 million records that we have. However, we start always from the batch that was failed at the end. As a result, we automated our pipelines into scalable, fault-tolerant pipelines that generated tailored summaries for all of our transcripts that we had. Finally, I'm going to present how we are moving away from the siloed manual processes of the past to a new era of enterprise-grade observability. So our old processes were defined by isolations. Experiments were not monitored, and we couldn't understand how the users were actually using our tool. Files during testing was spread into different folders, sheets, and it was very difficult for us to understand what went wrong and how to find the results when time goes by. We didn't have a shared and unified view, which made the collaboration with our team very difficult. And we couldn't also track costs and trends or failures. Today, that changes. We integrated with an enterprise-grade platform, and now all experiments are in one place. This also helped a lot for the team-wide visibility, and we can also see how the users are actually using our tools. We now have organized history, where we are logging and have auditable experiments. Now the debugging is instant, and we can identify very quickly the root cause and fix it into minutes. And finally, we have the powerful analytics in order to see the performance and the cost of using different tokens. Ioanna?
Yes. Thank you. So far, we have talked about what these agentic systems can do. What comes next is basically making sure that they can do it reliably at scale, as well as in a way that business can actually trust. So first of all, we are investing in evaluation and observability, so that we're not just asking whether a question and answer sounds right, but if it's genuinely accurate. We aim to do that by building an automated, scalable, and context-aware evaluation framework that is tailored to the user. It's tailored specific for agentic workflows. And this is powered by the RAGAS methodology, which allows us to systematically assess relevance, correctness, as well as semantic alignment. So this is critical for consistent performance at scale, cost efficiency in LLM usage, as well as minimizing the risk of misleading or hallucinated answers. One of the key challenges here is how we can create at scale, at large scale, high quality benchmark datasets that are able to support automated testing pipelines which reflect real world complexity. Secondly, we're upgrading our retrieval layer, improving indexing, chunking, and semantic search so that our systems miss less context and produce answers that are firmly grounded in the real data. So ultimately, the direction is higher trust, higher accuracy, and an infrastructure that scales responsibly as the intelligence grows. Thank you. Thank you. I don't know if anybody has a question for us. If not, then thanks a lot.